All right, let us go through this bell work. The first one's pretty nice because it says state whether it's a function. If it is a function, then you have to state the domain, the range, increasing, decreasing, and all that jazz. Is the first one a function? No. So it's not even a function, so I don't have to do the rest of this stuff. Not a fun guy. All right, our next one is, in fact, a function. It passes the vertical line test. Each letter goes to one mailbox. That means I need to state the domain, the range, and the intervals in which it's increasing, decreasing, and constant. For our domain, you should have came up with negative infinity to infinity. It covers all of the x values. X values are our domain. So our graph covers all of the x values. Any x value I plug in would result in an answer. Our range, however, is not all values. It is how low to how high we go. Well, if I put my finger on this graph, this is the lowest point I can get on this graph. That looks like it's about 1. And it looks like it includes 1. So I'm going to bracket 1. So our range basically, starts here and then goes up forever. So it's going to go 1 to infinity. Once again, range is the only one you're looking at your y values. It is the only one you're looking at your y values. So if you ever find yourself using your y values, you better be talking about range. Because the next thing is increasing, decreasing, and constant. Let's do increasing first. Well, I know I have to use the x values. I have to use parentheses. And Pierre, the mountain climbing ant, can only go left to right. So I'm looking for an ant walking across my graph going left to right. And when he's going uphill, starts right here. So right about at 3. What would actually show up? Purple, maybe. So we're looking at right here. He starts walking uphill. So that looks like it's about 3. So we're going to use parentheses 3. And he looks like he has to go uphill for the rest of his life after that. So he goes from 3 to infinity. Now let's do constant. Our constant, it looks like he's going constant between my 2 purple lines right there. So it looks like he's going 1 to 3 being constant. So that would be the interval 1, common 3. And then he's finally decreasing. Well, he's decreasing from negative infinity all the way until he gets to 1. So negative infinity till he gets to 1. Are there any questions on any one of those 5? I stress, you have to know how to do domain, you have to know how to do range, you have to know how to do increasing, constant, and decreasing. I guarantee that's on the test a couple times. All right, I guarantee it. And some of them might be just a graph like this. I expect it to be a quick, simple problem that you get all the points unless you actually use brackets or something like that. But that's not going to be the end of the world. What's the only one we use our y values on again? There's only one up there we use y values. Range. It is the only one you're using a y value. Thank you, Fritz. All right. Questions from the homework? Yeah, 21 says we have y squared equals 1 minus x squared. I guess you have to remember what a circle is on that one. You have to remember what a circle is because this is, in fact, a circle equation. So let's look at 21. 21 is y squared equals 1 minus x squared. Well, we could, so there's one way to think about this. The first way is, remember your circle formula. It's x minus h squared plus y minus k squared equals 1. Well, actually, it should be r squared. Well, in this case, if I would move that x to the other side, we would have x minus 0 squared plus y minus 0 squared equals 1. Now, I just moved the x to the other side. So I added x to the other side, and I kind of put it in this formula. Note that what I'm really looking at is this is really just x squared plus y squared equals 1 when I move the x over there. But according to my circle formula, that means that it's a circle that has a center at 0 and a radius of 1. So on the xy plane, we would have a center of 0, and we'd have a radius of 1. Negative 1, 1, negative 1. So this would be the circle that is formed. So that means our domain goes from x values negative 1 to 1, and our range goes from x or y values of negative 1 to 1 as well. If you didn't realize that this was a circle, you could have still handled it like a normal thing. So say you didn't realize it's a circle. Anything with x squared, y squared is a circle, but if you didn't realize that, you would just take the square root of both sides. We come up with y equals plus or minus the square root of 1 minus x squared. Now the only thing that doesn't work underneath the square root is a negative number. So you'd be looking for x values. So that can't be negative. So I'd be looking for x values that are bigger than or equal to 0. Well, I guess I would subtract 1 on both sides. We come up with negative x squared is greater than or equal to negative 1. Divide both sides by negative 1. We come up with x squared is less than or equal to positive 1. I would take the square root of both sides, and we end up with x needs to be less than or equal to just 1. Well, less than thing is an and. So our x has to be less than 1. Well, the only problem with that is we're plugging in x squared. So when I take the square root, we're actually looking for a positive or negative 1. So it has to be between a positive and a negative 1. I think the easiest one on this one is really just to look at it as a circle. X squared, y squared is a circle. All right, other questions? Yeah? 13. 13 says x equals y squared plus 1. So we have x equals y squared plus 1. Well, if I subtract 1 from both sides, we would have x minus 1 equals y squared. If I took the square root of both sides, we'd have plus or minus the square root of x minus 1 equals y. All right, so let's think about this kind of holistically wise. So let's take a break from that problem for just a second. Let's talk about y equals square root of x. That is a parent function that we did yesterday. Y equals the square root of x is going to be this equation here. That is y equals square root of x. If I did y equals the square root of positive or negative x, we would have the downward motion of that. So what this graph is this graph shifted over one space. If you didn't recognize that, you could also do this whole thing where you need to say that, well, x. So if you didn't recognize that, you could also do this part where we can say, well, x minus 1 must be bigger than or equal to 0 because it can't be negative. So x must be bigger than or equal to 1. So that's my domain, and my range is what I'd get out. Well, if I plug a 2 in, I'd have 2 minus 1, which would be the square root of 1, but then I'd have positive and negative 1. So it'd go on both sides. The y would just keep going on both sides like that. Okay? Other questions? Questions going once. That's it. Twice. Any stragglers? All right. Then today we're going to talk about piecewise functions. Piecewise functions are just graphing functions, but just part by part by part. So we can create functions that behave differently based upon input x values. So an example of a piecewise function is down here. We set up restraints on each function. So in other words, we say when x is less than 2, we're going to graph x squared. So we'd find x equals 2, and anything to the left of it will be our x squared graph. Then it says if x is exactly 2, we're going to plot 6. Well, that means at 2, there's going to be a point at 6. Finally, it says if x is bigger than 2, we are going to graph 10 minus x. So this is the line 10 minus x. So really what we're doing is we're making a Frankenstein graph. We're saying if I'm in this location, I'm going to graph this. If I'm in this location, I'm going to graph this. If I'm in this location, I'm going to graph this. And then we put it all together. Note, when you do a piecewise function, it will always still be a function. If I did the vertical line test on this, there is no place where it's hitting 2 points at once. The only place that looks fishy is at 2. But notice that empty hole means there's not a point here. There's just 1 point, and there's not a point here. So this passes the vertical line test. If you're ever doing a piecewise function, I tell you it's a piecewise function, and you graph something on top of something else. So imagine if I did this, and maybe I had this line continuing on. That would no longer be a function. It would fail, and you made a mistake. So if I said graph the piecewise function, and you no longer have a function, you made a mistake. All right, let's start with kind of a traditional one. It says graph the relationship and state the domain and range. So we're supposed to graph 1 if x is less than 0, and we need to graph -1 for when x is greater than or equal to 0. Note, if f of x equals 1, we're really talking about y equals 1. And for this one, I'm talking about y equals a -1. So we're talking about horizontal lines. I find the easiest and quickest way to graph piecewise functions is to look at where we have to change graphs. When x is less than 0, I do one graph. When x is greater than or equal to 0, I do a separate graph. So what I do is I find x equals 0, and I actually put a dashed line going down it. And the reason why I do that is because something on the left-hand side of this should be one graph, and on the right-hand side of this should be the other graph. Because if we look at the left-hand side is where x is less than 0. The right-hand side is where x is greater than 0. That can make this a lot easier to graph. Because I look at the left-hand side, it says, find out where x is less than 0. So I find that in here. Well, it says when it's less than 0, we're going to graph y equals 1. Y equals 1 will be a straight line at 1. And it's going to go this way forever. Now it says when I'm on the right-hand side, when x is greater than 0, I need to plot y equals a -1. So we are going to put a -1 in this direction. In order for this to be a function, only one of these can exist on this vertical line. If both of them have a point here, so if I have a point here, it would fail the vertical line test. That would no longer be a function. So one of these needs to be an open dot. We're going to know which one's the open dot because one has an equal to sign and one does not have an equal to sign. So this one has an equal to sign. So this one is going to be where our closed dot is. So I'm going to find my y is -1. That's going to be a closed dot. And if we look at our y equals 0, that one's there's no equal to sign, so we're going to put an open dot there. Open dot, No equal to sign. Equal to sign means I'm going to do a closed dot. Now I'm supposed to state the domain and the range. Well, our domain is how far left to how far right it goes. It goes forever in the negative direction. I come across, I know there's an open dot here, but it's covered by this one. So if I input 0, I get this out. So it actually goes from negative infinity to infinity. Our domain is negative infinity to infinity. Our range is slightly different. Who wants to take a shot at what the range is? Rena? -1 and 1?
Yes.
Yep. Just those 2 points, though.
Oh.
It is just those 2 points. Because can y ever be 0? Can I ever get 0 out of this input? No. It is, in fact, only -1 and 1. So we're actually going to use braces. We're going to say it's -1 and 1. It is those only 2 points. Because y can only be 1, or it could be -1. It can never be 2, 3, 4. The graph never covers that. It is straight left and straight right. So our domain is negative infinity to infinity. Our range is just -1 and just 1. Our next one says graph the relationship and state the domain and range. So this one says if x is between -2 and 2, we're supposed to do the graph x squared minus 4. When x is greater than 2, we're going to do x is minus 2. So what I'm going to look at is the turnaround points. It says when we're between -2 and 2, we're doing one graph. So what I always do is I go down -2 and put a vertical line. I put a vertical line at 2. And I just note to myself, between the lines are where x is between -2 and 2. To the right of 2 is where x is greater than 2. Now all we have to do is just plot some points. When I'm between -2 and 2, I'm supposed to use this x squared minus 4. So what I'm going to do is I'm just going to plot each of those points between the two. Or I can just plot one, middle one, and this one, because we know what x squared looks like, right? Isn't that U shape? But I'm going to go ahead and plot each of these 4 points. So let's plot -2, -1, 0, 1, and 2. Well, if I put -2 in, we'd have -2 squared, which is 4. 4 minus 4 is 0. If I plug -1 in, I'd have -1 squared, which is 1. 1 minus 4 is a -3. 0 squared minus 4 is a -4. 1 squared minus 4 is a -3. 2 squared minus 4 is also 0. So we're going to go ahead and plot those points. At -2, we have 0. At -1, we have -3. At 0, we have -4. At 1, we have a -3. And at 2, we have a 0. Now, the big thing we have to be aware of is whenever I'm putting a dot on one of these dashed lines, it's either going to be an open dot or a closed dot. So what you're going to do is you're going to go to that equation and ask yourself, is there an equal to sign or is there not an equal to sign? If there's an equal to sign, you put a closed dot. If there's not an equal to sign, you put an open dot. So if I look here, for that -2 is less than or equal to x is less than or equal to 2. Both of those have equal to signs. So at my -2 and 2, I'm going to have a full closed dot. And note those red lines are kind of our walls. So we need to stop at both of them. We're not going to do any arrows. We're just going to stop at those points. All right, now when my x is greater than 2, we're going to use the other equation. The other equation is that x minus 2. Well, that's a straight line, so I just need a couple points. Let's do one at 2, where the changeover point is. Let's do 3, and let's do 4. If I plug 2 in, 2 minus 2 is 0. If I plug 3 in, 3 minus 2 is going to be 1. 4 minus 2 is going to be 2. So I need to plot the point 2, 0, 3, 1, 4, 2. Well, note 2, 0 is already occupied by this point here, so we're just going to leave that. 3, 1 would be this point here. And finally, 4, 2 would be this point here. So we'd have a line that looks like that. We are supposed to do the domain and range. Can someone give me the domain of this one? How far left to how far right does this go? Brody?
-2.
Yep.
With the bracket 2.
Perfect. So it's -2 with a bracket to infinity. The farthest left is a -2. The furthest right is infinity. Range are going to be our y values. It's low to high. What's the range of this one? Oh.
-4 with a bracket.
Perfect. -4 with a bracket to infinity. Our lowest point is -4. Our highest point is forever in the sky. All right, questions on that one? Yeah, Brody.
So you graph the 3 and 4 with an open circle, right?
The 3 and the 4.
Like the points, you would make them open. I mean, you did actually.
Here?
Yeah.
No, these are closed.
Even though it's...
The only one we're worried about is on this line.
Oh, okay.
So technically when I plotted 2, 0, so what Brody's kind of talking about is we know it's just a greater than symbol. So at this point right here, so if I look at 2, 0, technically I did an open point for that. But because it's on top of a closed point, you can't see that it's open.
Okay.
If this would have been shifted up more, you'd see a big open dot there. But because it's in the same place as a closed dot, we can't really show it's open there. So we just don't do anything with it.
Okay.
So technically at 2, 0, there's an open and a closed point, but you can't see that because the closed point covers up the open point. Our next one is graph and identify any open intervals where the function is increasing, decreasing, or constant. All right, so we have 4 minus x squared, so we're just going to plot some points on it. We're just going to do -2, -1, 0, 1, and 2. Well, when I do this one, we have 4 minus a -2 squared, which would be 4 minus 4, which is 0. Then we're going to have 4 minus 1, -1 squared, which would be 4 minus 1, which is 3. When I plug a 0 in, we have 4 minus 0, which is 4. Then we're going to have 3, and then we're going to have 0 again. So we have -2, 0. We have -1, 3. We have 0, 4. We have 1, 3. And finally, we have 2, 0. Note, they didn't put any restrictions on this. So that means it's the entire graph. We're going to have arrows. There is no restriction on this graph. So if there's no restrictions, you have to put your entire arrows. Where's this graph increasing? Yeah. From -infinity to 4. No. I see what you're saying, but you made a mistake. When is this increasing? Mary? -infinity to 0. We're looking at the same thing, but you have to use your x values. It has to be x values. Like I said, the only time we're going to use your y values is on range. Now is the time to make those mistakes because it is really easy to go -infinity to 4. It's increasing. But then you'd say it's decreasing from 4 to negative, which wouldn't really make sense. So we're going left to right. So it'd be -infinity all the way to your x value being 0. left to right. And it's going up from negative infinity until it gets to x equals 0. That must mean it's decreasing the rest of the way. So that'd be from 0 to infinity. When is it constant? It's not. All right, last example. We're going to change this last example. We're going to change this one a bit. Instead of this square root of x, we're going to change that to square root of x minus 1. So we're going to put square root of x minus 1 in that place. So I'm going to replace that down here as well. Everything else will stay the same. All right, the first thing I'm going to do is I'm going to say I have 3 graphs I have to graph. We have one graph whenever x is less than 0. We have a graph when it's between 0 and 4, and we have one where it's greater than 4. So what I do is I look at every one of these numbers, and I put a vertical line. So I'm going to put a vertical line at where x equals 0. I'm going to put a vertical line at x equals 4. And that's actually going to cover all of my 3 possibilities. We either have x is less than 0, we have x is between 0 and 4, and we also have where x is bigger than 4. Those are my 3 sections I need graphs in. In each of these sections, I should have its own graph in there. Let's start out with x is less than 0. It says 0. But remember what 0 is actually saying. It's saying, so this section's actually saying graph y equals 0. So y equals 0 will be the straight line at 0. Oh, that's not going to show up much. Let's make that a little bit bigger. Does that show up? Can you see that line? Are we okay with this line here? That's my y equals 0. Now when I get to this dashed line, I have to decide is it open or a closed point. Is this blue line going to be open or closed on the dashed line? Is that open or closed? You know, it's going to be closed because y equals 0 is strictly an equal to sign. It's got a x is less than or equal to 0, so it's going to have a closed dot at 0. So that is a closed dot. All right, our next one is between 0 and 4. So let's go ahead. What's the first value that's going to work for that one? Let's change this one more. I don't like how this is working out. Let's change that to a +1. Yeah, let's change it to a +1. That will work better how I want it to look. All right, let's change that to an x plus 1. So 0 would work for that one. If I plug a 0 in for that, we would have a square root of 0 plus 1, which would be the square root of 1, which just equals 1. If I plug a 1 in for it, we're going to have a square root of 2, which is about 1.41. Let's plug a 3 in, because that we can actually do. If I plug a 3 in, we'd have a square root of 4, which equals 2. That will be enough to know what we're doing-ish. All right, so when I plug 0 in, I get a 1 out. So let's think about that 0.01. Then when I plug a 1 in, I get about 1.4 out. Then when I plug a 3 in, I get 2 out. And maybe our other point would be somewhere on here on 4. We could figure that out, but we're good. am I going to put an open dot or a closed dot here? Should that be an open or a closed dot there? Open or a closed dot? Make a guess. Put it down. Yeah. It would be an open dot. It would absolutely be an open dot right here. So this should be an open dot. In fact, I should erase that thing that's in the center. That should be an open dot. Do I have an open or closed dot at x equals 4? Open or closed dot at x equals 4. Flip. That would also be open because both of those are just less than or greater than signs. There's no equal to signs. So those would both be open dots. So it looks something like that. That's good enough. All right, the last one is I'm supposed to hit y equals 2 whenever x is greater than or equal to 4. So remember, this one is really saying y equals 2. There is an equal to sign. So at 4, we're going to have a closed dot. So we're going to have something that looks like this. Let's pick a different color. Let's pick purple. And then we go that direction. That is y equals 2 whenever it's greater than or equal to 4. So your things when you are doing these graphs, you have to specifically know where your graphs are located. I always use vertical lines to know one graph's here, one graph's here, one graph's here. Then you have to look at your less than signs and see if there's equal to signs. If there's equal to signs, closed dot. If there's not one, then we do an open dot. Brody.
Do you get y equals 2 just because it says 2 for...
Yep.
Okay.
So it's saying g of x equals 2, which is y equals 2. So they're saying y equals 0 for this, y equals this for this, y equals 2 for that. So whenever it's just a number, just remember it's just a horizontal line at that number.
Yeah.
All right, questions on that? Okay, then the rest of the time is yours to work.